Properties of some special matrices such as unitary matrices, idempotent matrices, and involutory matrices. Properties of unitary matrix, idempotent, matrix, and involutory matrix. Involutory matrices. Very important concept related to properties. First property of unitary matrices. So put title properties of unitary matrix. Unitary matrix. First property related to unitary matrices is if A is an unitary matrix, then A transpose is also a unitary matrix. If A is an unitary matrix, then A transpose is also unitary matrix. And in the case of orthogonal, same result hold. If A is an orthogonal matrix, then its inverse is also orthogonal and its transpose is also orthogonal. Second property is if A and B are two unitary matrices of same order, then AB and BA are also unitary matrices of same order. If A and B are two unitary matrices of same order for multiplication, matrices of same order, otherwise product will not be defined, then AB and BA are also unitary matrices. Third property is if A is unitary matrix, then A inverse is also unitary matrix. If A is unitary or orthogonal in real case and unitary in all case, either complex. Unitary, then A inverse is also mention real orthogonal, also unitary or real orthogonal. Now properties of idempotent matrices. Properties of idempotent matrix. First property is an idempotent matrix is necessarily be square matrix. It is necessary condition. An idempotent matrix is necessarily B square matrix. B square matrix. Second property is, if A and B are idempotent matrices of same order, then AB is idempotent if AB equal to BA, means if they commute. If A and B are idempotent matrices, idempotent matrices of same order, of same order, then AB is idempotent if and only if AB is equal BA, means if they commute. Next property related to idempotent matrix is, if A and B are idempotent matrices of same order, then their sum is idempotent if and only if they commute and equal to 0. If A and B are idempotent matrices of same order, of same order, then A plus B is idempotent matrix if and only if AB equal to BA, means they commute and equal to 0. Next property is, if A is idempotent matrix, then A plus B equal to identity, then B is idempotent, and same condition of this one is true, means condition of third. If A is an idempotent matrix, an idempotent matrix and A plus B equal to identity, then B is idempotent. Idempotent if and only if AB equal to BA and equal to 0. If A is idempotent, then A plus B equal to I, and B is idempotent if and only if this is not if and only if, then B is idempotent and not if and only if, and A plus B, then B is idempotent and AB equal to BA equal to 0. Now it is perfect. Fifth property is, diagonal matrix of diagonal elements is 1 1 1 is an idempotent matrix. This diagonal matrix is nothing. Unit matrix is idempotent matrix, means identity matrix of all size or any size is idempotent matrices. If lambda 1, lambda 2 and lambda 3 are direction cosines, then the matrix, if lambda 1, lambda 2 and lambda 3 are direction cosine, then the matrix is defined as lambda 1 square, lambda 2 square and lambda 3 square in diagonal square. This is lambda 1, lambda 2 and last one is lambda 1 with lambda 3. Now lambda 1, lambda 2, lambda 1, lambda 2, lambda 2 square, lambda 2, lambda 3, lambda 1, lambda 3, lambda 2, lambda 3 and lambda 3 square. This matrix is an idempotent. Last property is related to idempotent matrix is if A be equal to A and means prefactor and BA is equal to B same as prefactor, then A and B are idempotent matrix. Now some properties related to involutory matrix. Properties of involutory matrix. First property related to involutory matrix is identity matrix is always involutory matrix. Very common. Identity matrix is always orthogonal, involutory and idempotent. Means identity matrix satisfy almost all condition but not of skew symmetric matrix. Remember this point. It satisfy A equal to A transpose means symmetric, A transpose equal to A inverse, then again true, and in unitary matrices also, and idempotent, but this is not skew symmetric, is always involutory. Identity matrix is not skew symmetric because we cannot find negative of identity matrix, means the property identity transpose equal not equal to minus identity. That's why this is not symmetric. Second property related to involutory matrix is involutory matrix. A matrix A is involutory matrix if and only if A minus I and with product sum or take in first A minus I or I minus A or I minus A or I plus A is equal to 0. This to 0, then we say if means their sum A square, this is look like A square minus B square means product of one time sum and difference, then their product should be 0. Then we say this is involutory matrix. These are few properties related to unitary matrix, idempotent matrix, and involutory matrix.